theory, photoelectric effect should be able to occur at any light wave frequency. Secondly, bright light which has higher energy should be able to emit the electrons quickly. And lastly, dim light which has lower energy needs a longer time to absorb enough energy to escape from the metal. However, this theory is opposite with the photoelectric experiment. When a metal surface is illuminated by a beam of light at a certain frequency, the electrons can be emitted from the metal. This phenomenon is known as photoelectric effect. The characteristics of photoelectric effect. Number 1. The higher the frequency of the photon light, the higher kinetic energy of the photoelectrons is emitted from the metal surface. Number 2. The minimum frequency of light needed for a metal to emit the electrons from the metal surface is known as threshold frequency for a metal. The kinetic energy of photoelectrons does not depend on the intensity of light. An increase in the lack of intensity would not produce photoelectrons with higher kinetic energy. To make us understand better about the photoelectric effect, let's watch an animation where, let's say, I have three things. I have a golf ball, an inflatable ball, and a wood block. Well, let the size of the ball be as the brightness of light, and the mass of the ball will be as the frequency of light. Well, when I throw the inflatable ball into the wooden block, the wood block does not fall down. But when I throw the golf ball into the wood block falls down instantaneously. Well, what does it mean? Well, this situation shows that the size of the ball won't determine if the block can be fall down instantaneously, but the mass of the ball does. Even the golf has a smaller size compared to the inflatable ball, but with a larger mass, the ball can fall down the block instantaneously. So, what is connection between this situation with the photoelectric effect? Well, same goes to the brightness of light and the frequency of light. A bright light can't emit the electrons from the metal surface if the frequency is not good enough to emit the electrons. In 1905, Albert Einstein introduced a photoelectric theory that successfully explained all the characteristics of photoelectric effect by related experiments. He was awarded the Nobel Prize in 1921 for his achievement. This theory is known as Einstein's photoelectric theory. Say we have a metal with a work function of 3.50 times 10 power of negative 19. Work function is the minimum energy required for photoelectron to be emitted from a metal surface. Can a blue light with frequency of 6.66 times 10 power of 14 is able to produce photoelectric effect? First of all, we need to know its energy by using the formula of E equal to Hf. So we have to multiply 6.63 times 10 power of negative 24 with 6.66 times 10 power of 14, then we will get 4.41 times 10 power of negative 19. If the E is equal or exceed the work function, the threshold frequency is achieved by the light. Threshold frequency is the minimum frequency for a light photon to be produced, a photoelectric effect. Since E is greater than W, electrons will be emitted. By substituting these values in the formula of kinetic energy equal to photon energy minus work function, 4.41 times 10 power of negative 19 minus 3.50 times 10 power of negative 19 equal to 0.91. We can get the kinetic energy, thus the velocity of electron emitted by using kinetic energy equal to 1/2 mv squared. However, if we use low frequency, photoelectric effect won't occur.
To understand the applications of photoelectric effect, we must first understand how photocells work. A photocell functions as a switch in a circuit. It allows current to flow when it detects light and cuts the current when there is no light. It usually consists of a vacuum tube with 2 electrodes. The cathode is a photosensitive material such as cesium, while the anode can be any conductor. When light is shown on the photosensitive cathode, the photoelectrons emitted are attracted to the positively charged anode. This completes the circuit, thus allowing current to flow in the circuit of the photocell. The photocell is the most crucial component of most modern-day motion detector devices, such as the burglar alarm. Most motion detection burglar alarms primarily consist of a power source, a photocell, a light source, and an alarm. Under normal circumstances, the light source is always shown on the photocell, allowing current to flow in the circuit. The circuit is designed in a way which keeps the alarm off when current is flowing and triggers the alarm when current stops flowing in it. As soon as an object blocks the light from reaching the photocell, such as, the motion of a burglar, the current is cut off and the alarm is triggered. This mechanism is also widely used in automatic door or gate system. The photocell isn't only good at detecting motion, but it is also responsible in energy generation. Solar cells are made of the same kinds of semiconductor materials that is also photosensitive, such as silicon. For solar cells, a thin semiconductor wafer is specially doped to form an electric field, positive on one side and negative on the other. When light energy strikes the solar cell, the electrons are knocked loose from the atoms in the semiconductor material. If electrical conductors are attached to the positive and negative sides, forming an electrical circuit, the electrons can be captured in the form of an electric current, that is, electricity. A number of solar cells electrically connected to each other and mounted in a support structure or frame is called a photovoltaic module. Modules are designed to supply electricity at a certain voltage, such as a common 12-volt system. The current produced is directly dependent on how much light strikes the module. Multiple modules can be wired together to form an array. In general, the larger the area of a module or array, the more direct current electricity that will be produced. For example, the Noor complex solar plant in the Sahara Desert that is capable of producing 580 megawatt capacity for use of 1 million residents. Isn't that crazy?